Hello students, welcome back. In the previous session we discussed a few set of problems which are given in optional exercise, right? So we will do the remaining problems now. So those problems, so one of the problems is given that the third problem is find the center of the circle passing through the point, find the center of the circle, find the center of the circle passing through the points so the points given here are, the first point is going to be 6 comma minus 6, 6 comma minus 6, and the second point is going to be 3 comma minus 7, 3 comma minus 7, and the third point is going to be 3 comma 3, 3 comma 3. So in order to find center of the circle passing through these 3 points, you will have to draw one circle. So this is a circle passing through 3 points. For example, this is one first point A, and this is second point B, and let it be third point C, and we are going to find out the center of the circle. We do not know what is the center of the circle. Let it be some P x comma y is the center of the circle. Since the circle is passing through 3 points A, B, C, what do you mean by this? This point P being a center equidistant from all the 3 points, because this distance from the center to any point on the circle is called as radius of the circle, right? So that PA would be the radius, PB would be the radius, and PC would be the radius. So here let us consider first point is A, second point is B, third point is C. I am going to take those 3 points are A, B, C now. Let us consider the point A is 6 comma minus 6, and point B is 3 comma minus 7, and point C is 3 comma 3, and also the center of the circle is going to be x comma y. So here PA is equal to PB is equal to PC is equal to the radius. Since I am writing that information also, the radius is going to be PA, the length of PA, the line segment PA, or the distance between P and A, and the distance between P and B, and the distance between P and C, all are equal. Anyway, we know the formula for radius of the circle, which is the distance between the 2 points P and A, or the distance between P and B, or the distance between P and C. So I am going to find out the distance between PA, PB, PC. For that, I am going to write the formula for the distance. What is the formula for the distance here? Root over x1 minus x2 whole square plus y1 minus y2 whole square. See, I am going to find out PA first. PA is equal to, it means distance between P and A is going to be square root PA. So here A is 6 comma minus 6. If we want, we write here 6 comma minus 6, and B is going to be 3 comma minus 7, and C is going to be 3 comma 3. So distance between P and A is nothing but x1 minus x2 whole square, that is x minus 6 whole square, plus y1 minus y2 whole square is y plus 6 whole square. This is distance between PA, and distance between PB is going to be square root PB, that is x minus 3 whole square plus y plus 7 whole square. This is distance between PB, and similarly the distance between PC is going to be square root x minus 3 whole square plus y plus 3 y minus 3 whole square, right? So after finding the distances PA, PB and PC, now we know that PA is equal to PB is equal to PC. Therefore, I am going to equate any two distances there to figure out the value of x or the value of y if it is possible. See here, if you once observe clearly PA, PB, PC, which two distances should be equated first? You can equate any two distances, but if you once observe these two distances, Here x minus 3 whole square, x minus 3 whole square is there. When you equate both of them, then x minus 3 whole square will get cancelled. So directly you get the value of y. Hope you understand. Right. So I am equating both of them. PB is equal to PC. If PB is equal to PC, then PB square is equal to PC square. If I use this strategy, then I would get PB is equal PB square equal to PC square. When you square this, square and root gets cancelled, then we get x minus 3 whole square plus y plus 7 whole square is equal to PC square is going to be x minus 3 whole square plus y minus 3 whole square, right. Can we directly cancel x minus 3 whole square and x minus 3 whole square, because both of them are same. Then we left with y plus 7 whole square is equal to y minus 3 whole square. Here you need to understand one thing and think logically. Can we directly cancel square and square? That is absolutely wrong. We already discussed about this, that if x square is equal to y square, then x is going to be plus or minus root over y square, means x is equal to plus or minus y. So this is one simple logic that you need to remember instead of cancelling them both, right. So you will have to write it as y plus 7 is equal to plus or minus y minus 3. So y plus 7 is equal to plus or minus y minus 3. You should use plus first and then use minus. Y plus 7 is equal to y minus 3, or y plus 7 is equal to negative of y minus 3, correct. See, suppose if you equate both of them, then y and gets cancelled, it means 7 is equal to minus 3. That is absolutely wrong information. So that in this case you cannot get the value of y. And coming here, y plus 7 is equal to minus of y minus 3, so that y plus 7 is equal to negative y minus of minus plus 3. When you transpose negative y this side, y plus y is going to be 2y, and 3 minus 7 is equal to minus 4. So 2y is equal to minus 4, then the value of y is going to be minus 2. See, we got the value of y directly. And now after getting the value of y, you are left with PA is equal to PB or PA is equal to PC. You can equate any two things, absolutely fine. So I am going to equate PA and PB, and PA square is equal to PB square. So when PA square is equal to PB square, here PA square is going to be x minus 6 whole square, x minus 6 whole square plus y plus 6 whole square, but y is going to be minus 2. So minus 2 plus 6 is equal to 4, 4 square is equal to 16, that is PA square is equal to PB square. Again PB square is x minus 3 whole square, so x minus 3 whole square plus y plus 7 whole square, y is equal to minus 2, so minus 2 plus 7 is equal to 5, 5 square is equal to 25. So what has to be done here? Now you will have to expand, otherwise transpose this term here and transpose 16 towards right hand side, and then I am expanding this x minus 6 whole square is x square plus 6 square 36 minus 2 into x into 6 is equal to 12x, and transposing x minus 3 whole square towards left hand side, so that minus of x minus 3 I am expanding minus x square minus 3 3s are 9 minus of minus plus 2 3s are 6x, which is going to be 25 minus 16. So 25 minus 16. Now see here, plus x square minus x square gets cancelled, and this is minus 12x plus 6x is going to be minus 6x, and then this is 36 minus 9. So here 36 minus 9, this side you have 25 minus 16, so which is equal to 25 minus 16, and transposing plus 36 that side it would be minus 36, minus 9 would be plus 9, minus 6x is going to be, how much is this totally? It would be 25 minus 16 is equal to 9, 9 plus 9 is equal to 18, 8 minus 36 plus 18 is equal to minus 18, so that minus and minus gets cancelled, therefore the value of x is equal to 3. Therefore x is equal to 3 and y is equal to minus 2 means what is the center of the circle? The center of the circle is going to be 3 comma minus 2. So finally we got center of the circle as 3 comma minus 2. So this way we can answer the problem easily, and similar concept we do in +1 +2 or intermediate in the concept of coordinate geometry. Okay, in the concept of coordinate geometry we use the same concept, like when 3 points are given and they are at equidistant from a fixed point, in the concept called locus, right? In the concept of locus we do the same operations, so that this is very important concept also, right? Hope you understand how to answer this problem. So coming to the next problem that we are going to discuss, the next problem is going to be, so going to do the fourth problem, the two opposite vertices of a square. So I am going to do this, the two opposite vertices of a square are, what are those two opposite vertices of square? -1 comma 2, and what is the second vertex here? 3 comma 2, -1 comma 2 and 3 comma 2. So what are you asked here? You are asked to find the coordinates of the other two opposite vertices. So find the coordinates of other vertices. So in order to find this, in order to find out the other two vertices of a square, first of all you will have to draw a rough figure here. So this is a square, and here in which square, let it be some ABCD square. It was given that the two opposite vertices of a square, opposite vertices of a square means A and C are opposite vertices, B and D are opposite vertices. So for example, one vertex, if you consider A as -1 comma 2, its opposite vertex is going to be the C, that is 3 comma 2. These two are one pair of opposite vertices, but we do not know what is the other pair of opposite vertices. So let us consider first one of the vertex. Let us take this vertex B is x comma y. First let us try to find out the vertex B, and then we will think about C, right? So let us try to understand what are the properties of a square. First of all, according to the properties of a square and within the limits of our coordinate geometry, whatever we learnt so far, we learnt distance between 2 points formula, and we learnt section formula, and we learnt area of the triangle formula also, right? See which concept is pretty much applicable in order to find out the coordinates of the other vertices of the square. See, we know very well about the lengths of the sides of the square. The all sides of a square are equal. What do you mean by that? Side AB is equal to side BC, equal to side CD, equal to side DA, and we do not know about the angles. It means we do not know how to apply our coordinate geometrical concepts for angles. And if you observe the lengths of the diagonals of a square, the lengths of the diagonals are equal in a square. What do you mean by that? AC is equal to BD also. So anyway, we are going with one of the vertex B. So let us try to implement these two ideas. One is lengths of all the sides are equal, and second one is this is the diagonal, and how does this diagonal divide this triangle into two triangles of equal area, and moreover this triangle ABC is right angled triangle, and also it is right angled isosceles triangle. So right angled isosceles triangle means this is the diagonal. So hypotenuse square equal to side square plus side square. Anyway AB and BC both are equal, so the diagonal square is equal to either 2AB square or 2BC square, because AB square plus BC square is BC square equal to AC square, AB square. So that AB square plus BC square can be taken as 2AB square or 2BC square. So we can use that one more information also. So let us start finding. First I am taking the vertex A is going to be -1 comma 2, and the other vertex C is going to be 3 comma 2. Also we are going to take that point B as x comma y. Since all the four sides are equal, AB is equal to BC is equal to CD is equal to DA, we are finding the lengths. So, AB length, BC length, CD length, DA length are equal. I am going to find out the distance between AB and distance between BC since both are equal. So, I am going to write what is the formula for the distance. So, the distance between 2 points is going to be root over x1 minus x2 whole square plus y1 minus y2 whole square, right. So, I am taking AB and BC. So, AB is equal to BC. So, to remove the square roots, I will directly square here itself. AB square is equal to BC square. So, I will directly find out the distance between AB. That implies distance between AB is x1 minus x2 whole square. So, I am taking x minus of minus 1 x plus 1 whole square plus y1 minus y2 whole square is y minus 2 whole square is going to be now BC. BC is x minus 3 whole square plus y minus 2 whole square. See here itself, again I think we are getting the value of x directly because y minus 2 whole square and y minus 2 whole square both are same, right. So, why don't we cancel both of them? When you cancel both of them, then what are you getting here? X plus 1 whole square is equal to x minus 3 whole square. If x plus 1 whole square is equal to x minus 3 whole square, then we can say that just now we discussed about this, x plus 1 is equal to plus or minus x minus 3. So, when you use plus, you will get x and x cancel. So, that x plus 1 is equal to minus of x minus 3, then x plus 1 is equal to minus x minus 3, transpose minus x here and 1 that side. So, it is going to be 2x is equal to minus 3 minus 1 is minus 4, therefore, the value of x is going to be minus 2. So, we got the value of x. And to get the value of y, what has to be done here? We know that AB square plus BC square is equal to AC square. Since triangle ABC is right isosceles triangle, right isosceles. Since it is right isosceles, then we can say that AC square is equal to 2AB square, or else you can use 2BC square also. Okay, AB square plus BC square can be taken as AB square because all the sides are equal, right. So, AB square plus AB square is going to be 2AB square, which is equal to AC square. So, AC square equal to 2AB square or 2BC square. I am going to use this information. Consider one of them like AC square is equal to 2AB square. So, AC square means the distance between AC whole square. What is the distance between AC? Minus 1 minus 3 whole square plus 2 minus 2 whole square. 2 minus 2 whole square is equal to 2 times now AB square. I think we already found AB square here. This is AB square, right? X plus 1 whole square, x plus 1 whole square, or else you can use this one, no problem, y minus 2 whole square, y minus 2 whole square. So, in order to simplify this, minus 1 minus 3 equal to minus 4 whole square is 16 and this is 2 minus 2 is equal to 0 is equal to 2 times. Now, observe here x plus 1 whole square, but the value of x I think we got it as minus 2. So, that minus 2 plus 1 whole square plus y minus 2 whole square. When you simplify this, this is 16 plus 0 equal to 16, 2 1s, 2 8s are 16. So, finally, we get 8 is equal to minus 2 plus 1 is equal to 1, 1 square is equal to plus 1, right. And here minus 1 whole square is equal to plus 1 plus y minus 2 whole square plus y minus 2 whole square. Let me check once what has to be happen here. Minus 1 minus 3 equal to minus 4 whole square is equal to 16, which is equal to 2 minus 2 is equal to 0, and then 2 times x plus 1 whole square plus y minus 2 whole square. Since x is equal to minus 2, so that here minus 2 plus 1 whole square is equal to 1 whole square is equal to 1 plus y minus 2 whole square. Let me check once again before I get the final result. See here, two opposite vertices of a square are minus 1 comma 2 and 3 comma 2. Find the coordinates of the other vertices. See here, the first vertex is going to be minus 1 comma 2, yes, that is correct, and second vertex is 3 comma 2, right, minus 1 comma 2 and 3 comma 2. Let me once check. Minus 1 comma 2, 3 comma 2, AB equal to BC. So AB is going to be x plus 1 whole square plus y minus 2 whole square, and BC is going to be x minus 3 whole square plus y minus 2 whole square, that is correct. These two gets cancelled. X plus 1 whole square equal to x minus 3 whole square, so that x plus 1 is equal to, yes, here it is, x plus 1 is equal to minus x plus 3. So minus x plus x is equal to minus x would be here plus x. So and then it would be 3 minus 1 is equal to 2 here. So if 3 minus 1 is equal to 2, then what has to be done here? Yes, see here x plus x equal to 2x, 3 minus 1 is equal to 2. So 2x is equal to 2 means x is equal to 1. So when you substitute x is equal to 1 here, then it would be 1 plus 1 whole square. So 1 plus 1 whole square is going to be, what is 1 plus 1? 2 square is equal to 4. Now you can transpose 4 this side. It is going to be 8 minus 4 is equal to y minus 2 whole square. So 8 minus 4 is equal to 4, which is equal to y minus 2 whole square. Then what is the value of y minus 2 here? Y minus 2 equal to plus or minus square root 4. Therefore the value of y minus 2 is equal to plus or minus 2. So y minus 2 is equal to plus or minus 2 means when y minus 2 is equal to plus 2, you get one value of y, and y minus 2 equal to minus 2, you get one more value of y. Therefore the value of y, when you take plus, y minus 2 equal to 2, y is equal to plus 2 equal to 4, and another value of y is going to be, this is minus 2 gets cancelled, y is equal to 0. So why did we get two values of y here? Because we are going to find two opposite vertices, B as well as D. Suppose if the value of y is equal to 4, x is equal to 1, because there is only one value of x, there are no two values of x. X is equal to 1, y is equal to 4 is one of the vertex, and the other vertex is going to be x is equal to 1, y is equal to 0. So you can take one of the vertices x is equal to 1, y is equal to 0, and the other vertex is x is equal to 1, y is equal to 4. Either B can be here and D can be here, does not matter. So this way you can find out the other two opposite vertices of a square, and we have few more problems to discuss, but anyway all the concept is rotating around the only thing that we are going to use either distance formula, otherwise section formula, otherwise area of triangle formula. So this is what the very important chapter in our grade 10 CBSE curriculum, coordinate geometry, and it is very important in our examination point of view as well as in +1, +2 as well as intermediate also. So please be focused. Hope you understand. Thank you.